So some lessons learned and key messages. So from this guideline presentation for the integration and implementation of high temperature heat pumps in industrial processes, we learned that in principle we can save energy and reduce CO2 emissions with the heat pumps compared to fossil fueled heat systems. The guidelines help the technicians and the engineers and planners how to do and what to do, a stepwise procedure. It gives different insights into this integration, this integration work. We need to consider many things in such. It's a complex task, and it needs educated people, engineers. It includes economic and technical and socio-economic aspects. I would like to give this message. So we should apply pinch analysis or at least some similar method or tool to have an energy analysis and know better what are the streams and the temperatures, the heat demands, cooling demands. This is very relevant. And we need favorable electricity prices that are very essential for the economic business, so the business case at the end. Nicole Pierre showed in the ELSA case study that this is a retrofit project. It has many constraints, especially also the space. If you consider a milk producing plant, and so these are killing factors, and this has to be considered first. And then searching for an optimal heat pump integration solution has practical constraints, and it's complicated, has combinatoric and multi-criteria decisions. So the guidelines will help to filter out these candidates. The message is to gain process knowledge before making a decision. So this, I think, we can confirm in all the 3 case studies. We need to have good data and then decide. So this data collection and knowledge collection needs to be done first, and then later on consider a heat pump integration if it makes sense, yes or no. And also here, last bullet, the heat pump is hard to sell. Pierre showed that maybe also biomass, wood chips, is a competing technology, and has to be, that the heat pump has to be compared to other technologies. And then Nicole showed the Cremo case study. Here Nicole learned that the integration level, so the integration is technically feasible, even though it's at the 5th floor and with a 500 kilowatt steam heat pump. So there are suppliers available. In principle, this can be realized. The capacity is rather small for the heat pump, which makes the economic situation more challenging. But we can reduce here a lot of CO2 emissions. So if you go for decarbonization of industry, then a heat pump, electrical driven heat pump, in this case, MVR is a good technology, a possible technology. Key message, so this is a possible technology, a solution for industrial heat and steam decarbonization. Good knowledge of the streams is necessary, again, to find the best integration point between heat source and heat sink. Fundamentals are necessary, and it is always better to reduce the temperature first than having a very large temperature lift. So temperature reduction of the process streams is always one of the considerations. Do we really need high pressure steam, or do we can also work with a lower pressure steam at a lower temperature? And then there is a question mark at the end. So the operating costs, they be acceptable for CO2 emissions avoided? So it's also this economic question that needs to be answered in case by every case study. The costs are higher for these new technologies like high temperature heat pumps, and that makes it not so easy from the economic point of view. Then the case study Gustav Spies. Here, I would say we learned that in principle also technically such a high temperature heat pump could be realized. There is a waste heat available from the chillers. There are technologies available from suppliers, and we can save energy and CO2 emissions. Key message: sensitivity analysis to do that on the economic calculations, and very important to have measured data of the steam profile. So without that, we cannot make decisions, cannot decide how large the heat pump should be, and how large a storage, for example, a steam accumulator should be. And pinch analysis supports this decision making. Then Daniel showed the web integration tool, web-based integration tools. Here the lessons learned is that such tools are required for different means. They should have automated computational features, reporting tools to speed up this modeling and reporting on comparison of scenarios. Data handling platforms need to be, let's say, customer friendly. So Excel input file would be useful, and open access programming languages to, let's say, share this tool widely. And also the libraries are needed. Key message: so the tool needs to fit the customer profile, so the customer need. It needs qualified engineers, so need education. This is one of our tasks at the university as well, to offer courses for integration of heat pumps. And then open source tool, web scalability, and so on. There are many topics linked to such a web-based tool. Where does it run, on which data server, and confidentiality issues are also there, especially when it's about this process data, which should not be shared open widely. So last but not least, I would like to acknowledge our project again. So it's funded from the Swiss Federal Office of Energy, and here's the project number, where you then at the end of the project would find all our documents and also more reports than just these webinar presentations.